Hello, everybody. Welcome to Science Abounds, Science at Home, where we will discover home lab magic. In this channel, we will be performing experiments demonstrating scientific principles, concepts, and reactions in chemistry, biology, microbiology, microscopy, and even molecular biology. Welcome to my channel. Hello and welcome to another episode of Science Abounds, Science at Home, where we will discover home lab magic. In today's experiment, we're going to be looking at the chemical traffic signal reaction. This is a very popular reaction, and I'm sure you've seen it already on YouTube and Instagram, people performing the chemical traffic signal experiment. The reason why it's cool, very unique, and demonstrates a lot of important chemical redox reactions. And so it's a very fundamentally important reaction that everyone needs to learn about. So that's why I made the decision to make a video on the chemical traffic light reaction, because it is so important, it is so fundamental, and I thought, let's do it. So what you need for this is indigo carbon. Now, the traffic light reaction demonstrates a redox indicator called indigo carbon and changes color as a result of electron transfer. The introduction of oxygen through swirling of the solution causes the indigo carbon to turn from blue to green as it is oxidized. Now, in order to perform this traffic light experiment, we're going to need, obviously, indigo carbon, which I have here. We also need glucose, a solution of glucose, and a solution of sodium hydroxide to create an alkaline environment, which is very important for the reaction to successfully occur. So before we actually do the experiment itself, let's make up the solutions that we need. Okay, we need to make a glucose solution. So I've got my beaker here and a balance. So I need to weigh about 6 grams of glucose in about 6 grams. And then I'm going to dissolve that in the water. It doesn't have to be accurate. This experiment works at different concentrations, different strengths of solutions. And the ingredients really don't have to be exact. The reaction will still occur. This is my example of what we call bucket chemistry. It's just like throwing in the ingredients together, not really paying attention to how much we're using. It really doesn't matter. So then I'm going to add about 200 ml of water. That's fine. And I'm going to let that dissolve. Next, I'm going to make a solution of sodium hydroxide. Again, doesn't have to be exact. So what I want to do Stir my balance, and then I just want about 4 grams of sodium hydroxide. Okay, it's a bit much. You put that back. I went a little bit crazy. So about 4 grams. You don't need much. I don't think my balance is working very well today. Let me try that again. Okay, let me try again. Doesn't seems to be very sensitive today. All right. All right. I think I've got enough there. I don't need a lot. Doesn't have to be exact. And then I'm going to add 125 water. There we go. Let that mix. Okay. So for the reaction, I'm going to perform the reaction in the conical flask that I have here. So I've got all the solutions ready. So let's do the experiment. Well, that was the chemical light reaction demonstrating the redox indicator indigo carbon. Just to explain a little bit about the colors, the initial blue-green color that you saw is the indigo carbon being oxidized by oxygen in the air, causing it to appear to be green. This is the oxidized form of indigo carbon. The yellow-red coloration changes is where the indigo carbon is reduced by the glucose, which removes oxygen and returns the dye to its original reduced state, causing the solution to turn yellow. The intermediate red color that you saw is the formation of semiquinones. So let's talk a little bit about the reducing oxidation reaction. So indigo carbon reduction can be illustrated by the formula shown on your screen. The glucose oxidation can be illustrated by the second formula being displayed on your screen now. So, what is electron transfer? Well, in simple terms, electron transfer refers to the movement of electrons from one substance to another, which is the oxidizing agent. This transfer results in one species being oxidized, i.e., they're losing electrons, and the other substance being reduced, i.e., gaining electrons. In the context of the indigo carbon and glucose redox reaction system, the glucose acts as a reducing agent, donating electrons during the reaction. Glucose is oxidized, which means it loses electrons. The indigo carbon acts as an oxidizing agent, accepting electrons. Indigo carbon is reduced, which means it gains electrons. When indigo carbon is reduced, it changes color to green. And what about the sodium hydroxide? Well, the sodium hydroxide is added to the solution to create an alkaline environment. This is important because it helps in the electron transfer process and stabilizes the reaction. Well, I hope you enjoyed that little experiment, the chemical signal, traffic signal reactions, very famous. You can see it all over YouTube, Instagram, many people doing that reaction. But it is, as I said at the beginning, it is a fundamentally important reaction. Please, thank you to all my subscribers. If you're new to viewing, please hit the subscribe button. It's free and it helps and shows me your support so that I can continue to make more and more videos of varying different experiments. Please feel free to leave a comment, and also you can send me an email anytime with questions about science. If you have questions about chemistry, biology, anything about my videos, please reach out to me via email, and also send me your photos and your videos of you doing your own home lab experiments. I would love to build a home lab community. Until next time, keep on experimenting. Goodbye, everybody.